This video is about the objective make predictions using a line of best fit. All right, this is the second video on this objective. I'm hoping you watched the first one where I went over some of the notes from the instruction talking about interpolation and extrapolation, when a prediction is reliable versus unreliable, when a prediction is reasonable versus unreasonable. All right, so again, hopefully if you don't know what I just said, if you don't understand any of the words I just said, go back and watch the first video again. All right. So again, if you want to see more about it, the notes I went over and all that stuff, click on More Instruction. Look at their notes, their examples, their videos, and hopefully those help you out. All right, so here, data is collected on the relationship between time spent playing video games and time spent with family, both in minutes. The data is shown in the table, and the line of best fit for this data, which they're already given to us, so I don't need to enter these lists, and I'm not going to do that this time. I did in the first video. You can enter these lists and look at a scatter plot and graph the best line and see how they're related and all that. See how the line is pretty good at fitting the data, but I'm not going to do that this time. So y hat is, the slope is negative 0.2287 times x, and then plus the y-intercept 76.6. All right, assume the line of best fit is significant, right? So remember, you found the value of r, the correlation, say you found r, the correlation coefficient, and then you compared r to, critical values of r with 2 degrees of freedom here, because remember the number of degrees of freedom in those tables was n minus 2, the number of pairs minus 2. And you found the value of r was outside those critical values. Right, so then you would say that, oh, this is significant. The value of r is far enough away from 0 so that I can say that these variables, the time spent on video games and the time spent with family, I can say that these are linearly correlated. There is a strong linear relationship between the variables, and if that's the case, then I can use this best fit line to help me make predictions. If that weren't the case, right, if the value of r was insignificant, if it was too close to 0, right, if it was between the critical values, well then I would say that there's no linear relationship between these variables, and we shouldn't use the line as the best model for this data and try to find some other better model, maybe a quadratic or an exponential or something. But they're saying here we can assume the line is the best. All right, the line is good to model this data. All right, so we got the, spent 45 minutes on video games, 64 minutes with his family, and so on. All right, we got 4 ordered pairs. Notice that I'll say X represents video game minutes, and then Y represents time with family minutes. Right. Now the range of X, right, the values of X go from 45 to 90. So if I'm asked to plug in any values in between these two, I'll be doing something called interpolation. And those predictions will be reliable and reasonable. Right. If I'm asked to plug in values outside this range, less than 45 or greater than 90, I'll be doing what's called extrapolation. And those predictions will be unreliable because they're not within my range of data here. And they may or may not be reasonable. It all depends on whether or not the value you get could happen based on the data I currently have. Does it seem like that could happen? So let's see. All right. So according to the line of best fit, what would be the predicted number of minutes spent with family for someone who spent 120 minutes playing video games, and round your answer to 2 decimal places? So I'm going to, now the minutes playing video games, remember I called X, that was the input variable. So I'm just going to replace x with 120 in my calculator. So y hat, the predicted value, the predicted number of times spent with family, will be negative, use the negative sign, right? 0.287 times x, but x here is 120 minutes spent on the video games, and then plus 76.6. All right, so I would predict that if they spent, someone spent 120 minutes on video games, that person would spend an average of 42.16 minutes with their family. 42.16. Okay, so that's what I'll put here. Now what I just did, I'll submit this. Great. Let me go through the answer explanation. All that. Now that was part A, so there's going to be a second part to this problem. Now what I just did was called extrapolation. What I just did was called extrapolation because the value I plugged in, right, the value I plugged in, 120, is not within the realm of my inputs here, not within my data values. It's bigger than 90. And when you do extrapolation, you make extrapolated guesses. Those predictions are unreliable because they're not within the range of the observed data. So they're unreliable predictions, but they could be reasonable if they're within the realm of possibility. But they could also be unreasonable if the output is, not within the realm of possibility. Now, think about this. A person spending 120 minutes on video games, would spend an average of 42.1 people playing this much video games, this amount of time on video games, spend an average of 42.16 minutes with their families. That seems reasonable to me because that's a possible number. I mean, it didn't come up negative. If I plugged in 120 and it came up a negative number, that would be unreasonable because you can't spend a negative amount of time with your family. That makes no sense. But this 42.16 minutes positive, this seems reasonable. It's within the realm of possibility. So yes, I'm doing extrapolation. So the prediction I make is unreliable, less reliable than anything in between 45 and 90. But it is reasonable, this prediction, because it is within the realm of possibility. Again, if this came up negative, or if the number came up as some number of minutes that were longer than the number of minutes in a day, if it came up gigantic, I'd say, whoa, there's something wrong here. That's an unreasonable guess. But 42.16 minutes is reasonable. So this estimated time is, again, unreliable, but I'd say it was reasonable. Now let's see what they say. I may be wrong, but I feel like that's within the realm of possibility. So I'd say it was unreliable because we're doing extrapolation, but it's reasonable because this is a possible outcome. This is it. All right, great. All right, so just really pay attention. You got to pay attention to the scenario you're in. All right, what do these variables mean? So that way you understand, what's within the realm of possibility or not. What's an unreasonable answer versus a reasonable answer, a reasonable prediction. All right, great. All right, so I'm hoping after this, in my first video on this, maybe looking at the more instruction when necessary, reading the answer explanations when they come up. I'm hoping all this stuff helps you when you're working on this material on your own. All right, and thank you very much for watching.